All right, so when we're being asked for increasing and decreasing as well as the relative min, relative max, what we are going to do is we are going to first think about our critical numbers. Now, if we are doing this like to the book, what we would do is we would think about the domain first, and we would say that the domain is going to include where the denominator does not equal 0. That's what we need to include as our domain restriction. So we would start off with x minus 10. That denominator cannot be equal to 0, so x cannot be equal to 10. And this is our domain restriction. Now, a lot of times students will skip that step and it will fall out from the first derivative, setting the first derivative does not exist, that x is going to be 10, and then you'll see a condition there that results in that it would not exist. But formally what we would do is we would first say, okay, what is our domain? Then we would look at where is our derivative equal to 0 or does not exist. Now here you do have a variable divided by a variable, so the only way through that is the quotient rule. So setting up the quotient rule, I'll have 6x squared, x minus 10. The 6x squared will go to a 12x. The x is a linear term, so it will go to the coefficient of 1. And then the negative 10 is a standalone constant. So plugging into the derivative, remember that we are going to take 12x times x minus 10. Noticing that 12x is one term makes it easier to put that first because it is one term. So I'm going to put the 12x first and then the two terms of x minus 10 minus, and then this main diagonal, you'll notice I have 6x squared times 1. The times 1, of course, I can drop and just write it as 6x squared. And then that is over my b squared, my bottom squared. So that's going to be x minus 10 squared. Now, here is where we want to have one fraction. So because we want one fraction, what we need to do is we need to work in the numerator and remove our parentheses and then combine our like terms. And this is always going to happen with these questions with the quotient rule, is it's going to be the numerator that you're going to focus on, simplifying that numerator. So I distribute the 12x. That gives us 12x squared minus 120x. So again, my 12x squared and then the 12x times 10 is going to give us the negative 120x. And then minus 6x squared all over x minus 10 squared. Then I'm going to combine my like terms. I notice that I have a 12x squared and a negative 6x squared. Those combine together to give us 6x squared minus 120x over x minus 10 squared. And that is our first derivative. So now I'm going to set my first derivative equal to 0. That amounts to setting the numerator equal to 0. And then I'm going to set my first derivative does not exist. That amounts to the denominator equal to 0. When I set the numerator equal to 0, I have to solve this equation. And you'll notice that it's not as simple as undoing PIMDAS here because it is a square power. So because that is quadratic, I need to factor rather than undoing PIMDAS. So because that highest power is 2, I need to factor. When I factor, I first think about what is the GCF. So my GCF here would be a 6x. If I take out that 6x, I will be left with x minus 20 equal to 0. Now, we then set each of those factors equal to 0. So set the 6x equal to 0 and the x minus 20 equal to 0. You'll notice that this first factor does have an x, so you do need to solve for that. So I simply divide by 6 and get x is equal to 0. Then over here, add 20 to both sides, and I get x is equal to 20. Now, those two numbers actually are critical numbers because they are not domain restrictions. So those would be two official critical numbers. Meanwhile, when I set my denominator equal to 0, I have x minus 10 quantity squared equal to 0. I can undo that square power by taking the square root, or I could just go straight to, it's the factor x minus 10 that I want to set equal to 0. Add 10 to both sides, that gives us x is equal to 10. Now, as we discussed, this is technically not a critical number because it's a domain restriction. A lot of times students don't recognize that though. Either way, whether you call it a domain restriction or you happen to call it a critical number when it's not, it needs to go on the number line. Because remember with the number line, when we draw our derivative number line, we have to draw that with the domain in consideration. So here my domain consideration is 10, the domain restriction, and then the other two critical numbers are 0 and 20. So yes, we do now have 4 separate intervals that we need to plug into. When we plug in, we are going to plug in right before we set numerator and denominator equal to 0. So this is going to be f prime, the 6x squared minus 120x over x minus 10 squared. All right, so plugging in there, I'm going to have, oh, and the one thing I want to mention, by this point, you get kind of tired of plugging in. You can slightly improve your timing of this because with the quotient rule, you have a bottom squared. And anytime you have something squared, that is always positive. So technically, if you wanted to save yourself a little bit of time and energy, you could not plug into the bottom because you know that that bottom is b squared and you know it is going to be positive. So you could just completely not plug into the bottom and just plug into the numerator to determine this sign. So that is a little helpful hint, and it's going to come up a lot with the quotient rule because the quotient rule always has that bottom squared. All right, so here for the first interval from negative infinity to 0, I'm going to plug in -1. And again, I don't put the -1 on the number line because everybody's going to potentially plug in a different number. So I have -1 minus 10 squared. All right, now be careful with your arithmetic. We do not want to mess this up here. Double check it as much as you need to. Here I have 6. So I'm going to have a 6, and then the -1 squared will give us 1. And of course, you can put this in on your scientific calculator. That is perfectly fine. And then the -10 times, or -120 times -1 gives us a positive 120. So we are looking at a positive over a positive. Now, that positive tells us information about our first derivative. And when we're working with our first derivative, a positive indicates that we are increasing. So we're increasing on that first interval. Then for the second interval, I might plug in 1. So I have 6 times 1 squared minus 120 times 1 over 1 minus 10 squared. And again, you can work through this on the calculator, but this is going to be 6 minus 120. So that gives us a negative. In the denominator, it's quantity squared, so it's always positive. So that's going to give us a negative. So that negative tells us that we are decreasing. And it tells us we're decreasing because we're working with the first derivative. Then from 10 to 20, I might plug in, let's say 12. So I have 6 times 12 squared minus 120 times 12 over 12 minus 10 squared. So the denominator is always positive. Here we're dealing with the slightly bigger numbers, but if you plug this in, you will get, don't hit the tangent button when you're plugging in here, you will get a negative in the numerator. All right, that's interesting. That means that we're still staying as negative on that third interval, and so that means we continue to decrease. And then for the right interval, the rightmost interval, maybe you plug in 21. So let's plug in 22. Plug in 22. So 22 squared minus 120 times 22 over 22 minus 10 squared. Again, plugging that in on your calculator as needed gives you a positive over a positive. So that positive tells us that we are going up the hill. So just as a quick note here, I know my number line looks kind of messy. I want to quickly rewrite it. I have 0, I have 10, and I have 20. I had a positive, negative, negative, positive. What I would say is that it's increasing, decreasing, decreasing, and then increasing. So that number line, we would then say increasing on the interval negative infinity to 0, and then union 20 to infinity. It is decreasing. All right, now do not put the decreasing interval all together in one interval. We do need to maintain that split up interval. So it's decreasing on 0 to 10, union 10 to 20. And then of course we can use that number line to identify where we have a relative minimum. We have a relative minimum at this peak point. That would be at 0, comma, the y value. How do we find that y value? Well, it's simply an x comma y value. So we are going to go back to the original function. So my original function was the 6x squared over x minus 10. That's what we're going to plug into to find the y value. So here we'll plug in 0. So we have 6 times 0 squared over 0 minus 10. And that evaluates just to 0. So our relative min is at 0, comma 0. And as far as our relative max goes, relative max would be at 0, comma 0. And then our relative min, I don't know why I mixed those up for some reason. I'm pretty tired, I guess. All right, maybe I should stop for the night. All right, so our max is going to go up and then down. That's going to be our max at 0, comma 0. And then our min is going to happen at 20, comma. And then where we're going to put that 20 to get that x y coordinate, we have our 20, and then we'll have 6 times 20 squared over 20 minus 10. So we're going to do that arithmetic, again, plugging in to the original function. So we'll have 6 times 20 squared, so 2400 over 10. So that just gives you 240. So our relative min will be 20, comma 240. So again, I'm sorry I misspoke there, but max is definitely going to be the peak, and the peak is happening at 0, comma 0. And then our relative min is happening at 20, comma 240.